Hope you had a good visit to the library. Also looked at various resources that the library of IIT Madras Central Library, which is one of the most important digital media resource center for the whole institute and also for the country. Many people from outside come and use this library. So I hope you had a good academic visit there. Now, I'm very happy to introduce to you Professor and Dr. Balaji, B.S. Balaji. He is a professor in the Department of the School of Sciences, Chemical Sciences, or School of Chemistry, in School of Biotechnology, it says here, in the Jawaharlal Nehru University in Delhi. And he has been a close associate with us since a little earlier than the COVID times, when he wanted to participate in the massive open online course program of the NPTEL project, Swayam project at the time. And the Swayam NOC, he has been a contributor to the online examinations, online courses, several of them. I'll share his profile directly with all of you later. But more importantly, I would just introduce him as a professor dedicated to online teaching and learning and interactive teaching and learning in chemistry as a whole, and in particular organic chemistry. After his PhD, he was in the University of Missouri, Columbia, in the United States for several years as a research associate, and worked as a chemist, senior manager chemist in one of the companies in India at the time, Portland's Rivers Informatics. And later, he has served as associate professor and assistant professor in 3 universities before he moved to JNU, and where he is now for the last 6 years. His primary interests are organic chemistry, and he is an extremely avid publisher of offline courses. Apparently 19 times he has offered courses, and out of which BTech there are 12 courses, and the MSc there are 5 courses, and PhD 2 courses. So please refer to B.S. Balaji JNU in Google Scholar or in AI chat. You will see all the courses that he has developed for the benefit of students. And he has also developed teaching aids, several of them. And his primary education, of course, was in BSc, Madurai Kamaraj University, like all of us are. Today it's called Kamaraj University, but when I got the degree, it was simply Madurai University. And the same thing was Madras University at the time. And his MSc was in Manoramani Sundarnath University. He's also from Tirunelveli, and like me. And he has an MBA also from the university. So he's a very multifaceted and very well educated and very well erudite individual in chemistry, and I'm very happy that he is willing to talk to you for about 50 minutes. Dr. Balaji, the floor is on you.
Thank you, sir. Thank you for your nice introduction. And as you mentioned, our collaboration started just during the COVID time, and we are actually thankful for IIT Madras for giving us an opportunity to share the knowledge what we have been creating to the entire country. And without taking much time, I'll just go into my presentation. So is it visible now?
Yes, it is.
Okay. So I just want to talk about the competitive examination, how we can actually prepare. So this course, Logical and Systematic Approach to Solving CSIR Problems, had been in Swayam Prabha TV, and the playlist is there. We have created around 22 lectures specifically to address how you can actually prepare for competitive exam, especially CSIR examination. So the approach, how do we actually do that, is clearly given here. Currently, the CSIR examination is being conducted in the MCQ fashion. So the MCQ fashion, generally people assume that, okay, you close your eyes and say 1, 2, 3, 4 and then click it. So that way, this CSIR exams are not being done, because CSIR exams require you to think properly That is, logically you have to think. Of course, out of all the questions, there may be few questions where you can rule out some of the possibilities. Out of A, B, C, D, out of 4 options, you can actually rule out 1 or 2 options, but always there will be a competition between 2 options. Which one is the right one? In some cases, all the 4 options will be very similar. We have to choose the correct option. So how do we actually address this problem? So that I have explained very elaborately by taking around 200 problems from the CSIR examination, both from the part A and the part B one. That means the simplest one and the difficult one. So both the things are taken. And how we approach, that is the main thing we have discussed. And even for all of you, I can suggest is don't think subject wise, because learning for a subject is not the right approach. You can think about learning the entire thing as a whole, learning as a process rather than learning a subject specific one. Say, for example, today you are doing chemistry, let us say, because I started off with chemistry, so to say, but currently I'm working in the interface between biology and chemistry. If I had just focused only on chemistry, then I may not be able to switch my area, research area from chemistry to biology. So that is what is called chemical biology. That is the interface between chemistry and biology. So we have to keep our options open. So how do we do that? Simple. Rather than focus on the subject, focus on the process. So you can use the same thing for any problem, whatever you want to solve. The simplest thing is 3-question approach. The first question is why. The second question is what. The third question is how. Just ask these 3 questions to anything, whatever you want to do. A simple example I'll tell you. You want to travel. Why do you want to travel? Oh, there is a function. Maybe last month, a couple of weeks back, we had Pongal. So many of you, let us say you are in Chennai, but your village is in the southern part. You want to go. So the first question, why do you want to go? Then you will say, yeah, I have to, my friends are coming, this function is happening, so I have to go. So that why question is the first question you will ask. And then what? What you are going to do? Are you going to participate in the maybe kabadi விளையாட்டு இருக்கு, இல்லைன்னா கம்பு சண்டை போடுறது, ஏதோ சம், இல்லைன்னா ஜல்லிக்கட்டு இருக்கு, இந்த மாதிரி எவ்வளவோ ஈவெண்ட்ஸ் இருக்கு. அதுல how do I going to participate? So the second question is what. Then the third question comes is how are you going to go? Whether because train is full, so I cannot travel by train, so can I take bus, or can I take some other means? So that is what we plan. So the entire process is, I want to enjoy my vacation at my village. So for this, we ask these 3 questions: why you want to go, what you want to do, and how do you want to go. You remove that thing like a vacation, you put your subject. I want to clear CSIR exam. So why do you want to clear CSIR exam? Now, I want to pursue research. I want to become a teacher, because CSIR net gives you opportunity to become an assistant professor also. So that means I don't want to do research, but I want to be a teacher. So that option is also there. So that means that why question is the first thing you will ask, because anything and everything, whatever you do, starts with why question. The moment you can clearly understand the purpose of why question, then everything becomes very easy. Now you want to become a teacher, then adukku thagunda mari you start preparing. You want to become a researcher, then based on that you start preparing. So that second thing is what are you going to do afterwards, or what subjects, what books you have to study to clear this exam. So that what question can be anything you can ask to achieve the why problem. And now the third one is the how problem. So how are you going to do? How many days, how many hours you want to spend for this preparation? So do you want to prepare with your friends, or do you want to go to library to read the books, or you want to start writing your own notes? So all these how questions will come the third one. So if you can just use this process, anything and everything, whatever you want to do can easily be sorted out. The moment you do this, then it will lead to time management. So the next step is, how do you want to do? I want to spend 1 hour per day for this preparation. So now how are you going to do that? So I watch a lot of reels. I watch a lot of this thing. I do that. Like now you will find it out where you are actually spending more time. You cut down some of those things, now you will find lots of time. So the time management comes when you ask the question, how are you going to do that? So this is the overall process, and this can be applied to anything and everything. And I always follow this approach only. Even for today's session, why I want to give, that is the first question I ask. Oh, I want to share, I want to inform the students that what is they will get after they clear the examination. Because I'll tell you, the teachers are the best people, and we take lots of help from our teachers because they are the one who are guiding us. In fact, when I was doing my second year master's degree, I was doing in a college, rural area, நாகர்கோவில்ல நான் வந்து காலேஜ் படிச்சிட்டு இருந்தேன். அப்போ எங்கள் காலேஜில் வந்து we don't have anything, PhD is not known to any of us. Only thing what we know is one or two teachers of us had a PhD. They are called as doctor. Other people are just normal teachers. So this is the only difference I know. I have zero knowledge about PhD. But one fine day in the month of, I think, January or February, our teacher came and he told, I had put up a notice which had come in the employment exchange about CSIR examination. Please go and see the notice board. That is the only thing he said in the class. So we were actually 20 students at that time in our masters. So we all of us went to the chemistry department laboratory. So there is our notice board was there. So it was given like CSR examination and other things. So we don't know any idea what the CSR exam and other thing. Just we all know only one thing. They said you have to apply. That is the only thing. So we all took, okay, what is, and the nearest exam center was, I am from Nagarkovil, so the nearest one was only Trivandrum. So I have to go to Trivandrum to write the examination. So that is the only thing. And I thought, okay, let us apply and see what happens. And we just applied. So the starting point was, my teacher just told this to all the students, and very not all of them took a very keen interest, but 8 of us took an interest and 8 of us applied. But fortunately or unfortunately, I don't know, I could clear the CSR examination. Then I don't know where to do research. So then there were various institutes I went. Indian Institute of Petroleum in Dehradun. They have sent us, because back then, whenever we clear the CSIR examination, many institutes will write to us telling that you come and do research at our place. In fact, at that time, I don't even know that there is a difference between UGC net and CSIR net. These two difference also I was not aware of. And only my friends told, Balaji, there is a difference. One is a CSIR net and another one is UGC net. Okay, so this is how we were ignorant at that time. That does not mean that we cannot succeed. The only thing is we have to have an interest. We have to have curiosity, because research is driven only by curiosity. And I was very curious. Even during our MSc days, our lab attendant used to scold me a lot. Balaji, don't waste chemicals. Don't do this. Don't do that, like that. He used to scold me a lot because I mix many things just like that. We do inorganic radical analysis and organic experiments and other thing. I just mix two things and figure it out what it is and what that and like that. And we used to do it when the attendant is not there. Otherwise, he will scold us. So, but we had at least I had that curiosity that I need to know what is happening and other thing. So that was the real thing for me. And during the preparations for the CSIR exam, I never prepared separately for that exam, but I studied in Tamil medium. So up to 12th standard, I studied in Tamil medium. When I went to college, it was like a very difficult thing because the teachers were all speaking in English. I don't know anything. So I started making my own notes. I started reading the books. I took dictionary and started collecting one by one word. What is this meaning? What is that meaning? All those things I started doing one by one. So by BSc, when I started my first year BSc, I had 68% marks. But when I completed my BSc, I had 87%. That means 2 to 3 semesters, I scored more than 95 plus in all papers. So that is the effort I was putting on that you start your own notes or you prepare your own notes, then that is the real turning point. So that helped me a lot. Then in the MSc also, I continued the same thing. So that's the reason for CSIR, just for focusing CSIR, I never prepared, but I studied every day. I prepared my own notes, and here are some of the books which I also referred back then. One is March Advanced Organic Chemistry. So even though some of these books are at a little bit higher standard, but they discuss our subject very elaborately. We have to read at least 2, 3 different types of books. Then only we will understand whichever is giving in a simple way, you just take that part. Other things, if it is difficult, it's okay, but we will understand few things. But there are few other books which will tell the same concept in a different way. So try to understand, read from different books. That will give you the whole information about that particular process. So Jerry March was the only organic book I always referred because they talk about the reactions and then they will give the applications of that mechanisms. Whatever is talked in the beginning, everything is given back in the entire reactions. What are all the different types of reactions that are happening? Now, what we have to do as a student is now connect the dots. Like if for example, a base catalyzed reaction. Okay, how many different base catalyzed reactions are there? Okay, Diekmann condensation. We can name it like at least 10 to Henry aldol Michael addition, Henry nitro aldol reaction. We can Claisen condensation, even simple aldol condensation. So all these reactions involve catalytic amount of base. But there is one another reaction, benzoin condensation. When we talk about cyanide is the base, because when we simply look at base, hydroxide ion is the only thing which will come to our mind. But not necessarily hydroxide ion is the only base. There are also other nucleophiles. Now the next question comes. What is the difference between base and a nucleophile? So these are all the ways we generally look into. The base will simply abstract a proton. The nucleophile will add to the substrate. So this is where the difference. If we say OH minus, whether the OH minus is a base or the OH minus is a nucleophile is found after the reaction is over. Because you can use OH as a base for your reaction, but it can also behave like a base and it may even add to the substrate. For example, you take alkyl halide and treat with a base, then you may even end up with an alcohol. You actually wanted to conduct a elimination reaction. Your assumption was OH minus is a base, so it will abstract a proton and it will actually lead to the elimination product. But you end up with an alcohol, because in this particular case, the hydroxide behaved like a nucleophile. Now the question will come, who decides whether it will act like a base or like a nucleophile? So these are all the questions we should start asking. Now, if you go to the next level, you will try to understand why the same element, the same species behaves differently. Now you know aqueous conditions leads to hydroxide as a nucleophile. alcoholic conditions leads to hydroxide as a base. So why that difference comes? Now you will go in to understand the solvent effect for this particular reaction. So Rx plus NaOH or whatever you put is going to give alcohol or elimination product. That depends mostly on the solvent you use and not it is the hydroxide. So that understanding will tell you if you are conducting a chemical reaction, it is just not the substrate alone you have to look into. It is not just the reagent you have to look into. You also need to look into the solvent. So this is where our clear understanding will come if we start doing one by one by one. And for your CSR examination also, if you do this, then it will help you that, okay, because most of the time our mind tells OH minus means it is a base. OH minus means it is a nucleophile. That's it. But we will not look into under what conditions, under what solvent conditions that difference actually occurs. So if we look at the equation or any chemical reaction as a whole, then you will understand, oh, it is not very difficult to keep in our mind that solvent also plays a role. So what is the role of the solvent? Water can form hydrogen bonding. So when a nucleophile is there or when a base is there, what is the role of the solvent? Whether it can stabilize the anion or stabilize the base, then the reactivity completely changes. There is also another important reaction. We know about the Markovnikov addition reaction. Okay, we also know anti-Markovnikov addition reaction. So in both the cases, what is the crucial difference is the mechanism. One is an ionic mechanism, another one is a radical mechanism. So the explanations what you give for Markovnikov rule addition is not completely applicable for anti-Markovnikov addition because the mechanism is now completely different. So if you look from that aspect, then it will be very easy for you to understand how the entire process actually happens. So this is where many of the books talks about go to the detail, because if you want to be a researcher, one thing that is very, very important is observation. Because the anti-Markovnikov addition, if we talk about, some people also call that as a Karsh rule. So what is this scientist Karsh had done? He had carried out various experiments. He was actually conducting the experiment like a normal Markovnikov addition, but the alkene what he used had hydrogen peroxide in traces that nobody, because this was used as a stabilizer and nobody knows about it. And he tried various batches of this alkene, and then he finally found out, oh, this reaction goes in a very different direction. So he understood only one thing, that the reagent was actually stabilized by hydrogen peroxide, and the amount of hydrogen peroxide was in very, very minute quantity. But even then that was sufficient to create the radical reaction. So that reaction became only radical mechanism. Now, if you look very carefully, alkyl bromide only gives this reaction. Alkyl halide does not give, alkyl fluoride does not give, alkyl iodide also does not give anti-Markovnikov addition. Anti-Markovnikov addition is given only by alkyl bromide. Now the next question, why so? Why RF or RCl or RI does not undergo reaction but only RBr? Now we talk about the dissociation bonding energy. So this is a physical chemistry aspect. Now we are talking about an organic chemistry, but physical chemistry now comes in that what is the energy required to break this particular bond? And this is how we have to interrelate or connect the reactions. Organic chemistry means don't just focus on organic chemistry, because there is nothing called a single subject. Everything is interrelated. So from this, we will go on to understand the reaction mechanism. So when we try to understand the reaction mechanism, then we say reaction coordinate diagram. So that is purely physical organic chemistry aspects. We conduct a chemical experiment or chemical reaction, then see how fast the things are going, because we all know rate law and other things. For example, SN1 reaction or SN2 reactions, when we talk about, these are basically mechanisms. So how scientists prove the mechanism? By the physical chemistry experiments they conduct. So there is a relationship between physical chemistry and organic chemistry. So similarly, we can also identify many things. Any of your organic, for example, you talk about metal catalyzed reactions. When we say metal, basically we are moving into the domain of inorganic chemistry. So we have plenty of catalysts, ruthenium, rhodium, platinum, and we can list many of the catalysts. So all of them are inorganic compounds or maybe coordination complexes per se. To understand an organic chemistry which is catalyzed by these reagents, we also need to study about inorganic chemistry. We have to know what is the d-electron configuration, what is back bonding, what is coordinate bonding, and why certain things mainly the transition metals are very good. Why not the alkali metals? Why not the alkaline earth metals? So these questions we will start asking, then we will understand, okay, the d orbital actually plays an important role. Now, we will be going to the next one, how these reactions are happening. Basically, we need a base. The metal is in the higher oxidation state. That has to be reduced. Now, we come into understanding the chemical reaction using electrons movement alone. So forget about everything, because Lewis acid-base theory, when we talk about, we only talk about electron movement. Organic chemistry purely deals with electron movement only, nothing else. So in the electron movement, what do you need? Somebody has to give electron, somebody has to accept electron. That's it. So this is the simple thing. So who will give now electrons? Now you will talk into electronegativity principles. So what is electronegativity principles? Some species, some elements can accept electron very readily. Some of them can actually donate electron. That's it. So the moment you understand this simple difference, then we can actually define every reaction as an acid-base reaction, or we can define many reactions as a redox reaction. Simple. So starting from a reaction, we go into the reaction mechanism. The more and more, if you break down these as a simple stages, then the entire thing becomes very easy, because organic chemistry is nothing but pure logic. And sometimes the logic may work in a different way. You will ask, sir, in the previous case you said this, but in this case, for example, Markovnikov of addition, you said it is working or giving this type of product, and in the anti-Markovnikov, it gives entirely a different product. For example, you take Zaitsev rule and Hoffman rule. So in one case, you get the most branched alkene. In another case, you get the terminal alkene. So why do you get these differences? It is very simple. Now, the bulkiness of the base is the deciding factor in the elimination reaction. Whether it follows the Zaitsev rule or it is going to follow the Hoffman rule is purely dependent on the size of the base. So here, now we are going to understand the next stage, like how a base can approach the electron. So here we are talking about base. We are not talking about nucleophile. So this difference we have to keep in mind all the time. Like when that particular species will behave like a base depends on the reaction conditions. And what is actually a reaction mechanism? It is the path by which the reaction would have proceeded to give the product. So when do you know about the mechanism? We can only talk about mechanism after reaching the final destination. That means you start with an alkyl halide, then you end up with an alkene. This is what is the real observation. But how do I explain that this base gives this alkene and the other base gives a different alkene? How do I explain that? Now comes the understanding of the reaction mechanism. So if you are going to clear or if you are going to write any mechanism, we need to know what is the starting material. We have to know what is the product. Then we try to connect. Say, for example, simple thing, if some of you are from Chennai, I will tell one small example. Now you are in IIT Madras, let us say. From the IIT Madras, you actually want to go to, say, Saidapete. So what is the path you are going to follow? That many people can follow different type of path. Some people can take the shortest route. Some people can take the longest route. It doesn't matter. How do we know person A followed this path? Only thing is, we can actually identify or keep some checkpoints in between. Then if the person had crossed the checkpoint, then we know, yes, he went through this path. If he did not, then we know he did not follow that path. Similarly, the reaction intermediates are those check spots we have. And if we clearly understand the whole process, then it will actually give us more insights into how the entire reaction actually proceeds. So if you are going to solve any CSR examination or any chemical reaction, now you will be looking at the various aspects. The first thing is, what is the starting material? Then what is the product? Then what is the reagent? So now we have to break down these three informations what are given. What a substrate will do. See, substrate, when we talk about, we have to also look at the structure of the substrate. How big, how small, and what are the other groups which are present. Say, for example, if there is a inductively electron donating group or inductively electron withdrawing group or resonance donating groups. So whether these are present, then based on that, these molecular interactions are going to change differently. So inductive effect may favor some type of reaction. Hyperconjugation, if it exists, then they may take the reaction in a very different path. So the reaction mechanism, if you want to understand and then you want to predict that, we have to also look at each and every components of that entire reaction. For that, we have to actually learn or know many things. So the simplest thing is make a chart. A small chart, you make it and mention, okay, methyl group. What the methyl group will do, whether it is a plus I effect group or the structure or the steric hindrance, how much big it is. You have a tertiary butyl group, so how big it is. So like that, you make a list. Now you go to halogens, how much is their electron withdrawing nature, which is more electronegative. And like that, we create separate groups for each functional groups. Then you will now know if you are going to solve a particular problem when that particular functionality is there. So what are all it can do, we can find it out. And then in the final product, what is actually present. And if the reagent is there, what that particular reagent can do. So all those things we can categorize. The moment we do or we create our own way of notes, that is where it will help you solve many of the problems. And here is another Swayam Prabha TV. We have created a course on pharmaceutical organic chemistry. Here I had discussed about various reactions. And many of these things are freely available. The YouTube link is given here, and I will also be sharing this presentation with you. So you can actually go through all the videos. There is also another thing, this is at a BSc level, but then the reactions which are discussed here are at a master's level, because for your CSR examination, most of the reactions which are being asked in the question paper are actually explained in these kind of reactions. And what I try to do is, I try to give a holistic approach rather than one single reaction. Say, for example, if you take aromatic nucleophilic substitution and aliphatic nucleophilic substitution, a benzene ring cannot follow SN1 mechanism or SN2 mechanism. That is what we say. But unfortunately, that is not actually applicable. The reason is we only know mechanism is a path by which the reaction actually proceeds. What actually happens? A chlorobenzene can be converted into phenol. This is possible. This is a nucleophilic reaction, substitution that is possible. Similarly, alkyl halide can be converted to an alcohol. So, both reactions are happening. What is the main thing? A halogen is being replaced by a nucleophile hydroxide. Whether it is an aliphatic system or aromatic system, it doesn't matter. Both the reactions are happening. But then what is the difference? The path by which the reaction proceeds is the only difference. When we talk about alkyl halides, then we have two things. One is like a backside attack, SN2 type mechanism. That is to explain the product formation. Then we also have the carbocation mechanism, that is the SN1 mechanism. But these two things are not applicable in the case of aromatic system. Why? The aromatic system, the nucleophile is, if it has to attack the carbon on which the chlorine is present, the backside is completely covered by the rest of the other carbon atoms. So, and it is a planar molecule. So the nucleophile cannot come and approach from the opposite side. So that means SN2 type mechanism cannot work. Now, the next one is carbocation mechanism. Why that cannot work? Because phenyl carbocation is highly unstable. So that also is not possible. So we cannot use SN1 or SN2 type mechanism to explain the aromatic nucleophilic substitution. This does not mean an aromatic substrate is not undergoing aromatic nucleophilic substitution. So now this is where the extra understanding of the reaction mechanism helps. Now we are going to understand that, okay, SN1 type may not work, SN2 type may not work, but it can undergo by addition elimination or elimination addition type mechanism, because on the same carbon the nucleophile can come and attack. Then either it is the addition followed by elimination, or first elimination followed by addition, or both are possible. So this is how we try to explain the mechanism. But what is actually the observation? A chlorobenzene is converted to phenol. This happens, but our explanation may change. So this is how we write down the points for each and every reaction. Then once you have this clear understanding of how each things happen, then that will actually help you do that in a much better way. So you can create your own notes. That's what I said. Like, I mean, say, let us say one small thing I am talking about, changes happening during a particular reaction. So it may be a stereochemistry change, or it may be related to energy, or it may be related to structure. So these are all the three common things. But is it just sufficient to understand the chemical reaction? No, this is insufficient. So we have to add few more things. Now, when we talk about stereochemistry, you can add conformational changes. You can also add geometric changes. Then when we talk about energy, we can talk about the activation energy, that is the threshold, which is essential for the reaction to occur. Or we can also talk about the free energy, which leads to thermodynamically stable product. So now we are talking about simple energy into kinetic and thermodynamic control of a chemical reaction. Then when we talk about structure, we can talk about the functional group. Then we can bring in all the molecular interactions, like what is inductive effect, what is the resonance effect, what is hyperconjugative effect. Everything can be brought into the functional group. And also we can look at the properties. So these are all the additional things we can do. And now, if you want to make like a very nice presentation, you can also color it and other thing, because some students like to color so that they feel like, oh, it is really colorful. Or you can also go with the black and white, that is your choice. But then you try to have maximum information for each and everything. So that way it helps you to go through very quickly, because now you look at what are the changes happening in a chemical reaction, just point out one, like that, you can easily make it. So these are your way of making your own notes. And then what you can actually do is, the next is the mnemonics. So if you can develop some mnemonics, that will also help you remember many things. For example, I had just given 2 examples here. I am new to BSc. This is simply a statement. What does it mean? N means nucleophile, E means elimination, V means weak. So when the nucleophile is weak, it actually favors elimination. That is one way. And then BSc, that means when the base is strong, it also favors elimination. So these 2 things are done in one single sentence. So by remembering this, you can just forget the rest of the things. You can easily go through that. Okay, that means weak nucleophiles and strong bases favor elimination reactions. But I went to West Bengal state for NSS trip. See, these are like, you can just make up whatever you want, you just make up, because mnemonics have no meaning, so to say. This is only for you to remember. So what is this WBS and NSS? W here is a weak, B is the base, S is a substitution. So when the base is weak, that leads to substitution reaction. Then what is this NSS? N is the nucleophile, S is a substitution, S is strong. So that means when the nucleophile is strong, that favors substitution. So this way, you can easily relate the relationship between a nucleophile, its strength, and the it carries out. So all the 3 things can be combined in just 2 sentences. So this is what is called the mnemonics. This you can prepare on your own, whichever you feel like you can actually make it, but just make it, because these are all the shortcuts. Because when you are in an examination, you cannot think so many things and then you will completely forget, or even you will be confused. But you create these mnemonics, they are actually going to help you a lot. And about understanding the inductive effect, you can also use some books which actually explains it in a much more elaborate way. So the inductive effect, the halogen atom, is simply we know inductive effect is happening, but how do we scientifically, because we are scientists, we have to give evidences how this inductive effect actually operates. Now we talk about pKa of this hydrogen atom. So this carboxylic acid hydrogen. So here in the case of propanoic 1, 2, 3, 4, so it's a butanoic acid. So we have pKa of 4.8. But when you have the alpha chlorine, beta chlorine, and the gamma chlorine, we know the pKa values keep changing. So pKa low means it is strongly acidic. So that is how we correlate these 2 things. So that way, when you have the values, you exactly know. See, if you look at the 4-chlorobutanoic acid and the butanoic acid, the halogen is far away from the carboxylic acid, so it cannot inductively affect the carboxylic acid. So we can clearly say, yes, this is what is happening through scientific values. So similarly, if you want to understand the HSAB model, there are too many things which are given, hard and soft acids and bases. It's very difficult to remember. One simple example, what I will say is, hard means remember pearl. Pearl is small, okay? And that is the only thing you have to remember. So whenever we talk about the hard, then we say it is a small size, not easily polarizable. Polarizable means you assume that it is breakable. So it cannot be broken easily. So that means the hard, easily small size, not easily breakable, then everything is either hard or acid or base. Soft, remember balloon, it is very big, bulky, and you can easily break it. So that means soft species will have large size and they are either easily oxidized or they can easily be polarizable. So all those things you can correlate with that. And similarly, you try to correlate or you try to connect something, hard and soft acid base, you try to connect with pearl and soft balloon. That's it. So how do you get this idea is your own way of doing that. So that way, this entire hard and soft acid and base, entire thing can be brought down into just 2 things, pearl and the balloon. That's it. So similarly, the resonance stabilization, when we talk about, acetates are more easily stabilized compared to phenoxides. So why that is the reason? A simple thing, because in both the cases, resonance structures are there. In fact, if you look at the aromatic ring, we have actually more number of resonance structures than the carboxylate anion. So these are all the questions you should ask. Try to find the simplest. If you look at carboxylate, the negative charge is remaining on the oxygen. In the phenoxide ion, the negative charge remains on the carbon. Now the electronegativity principle comes into play. Oxygen is more electronegative than carbon. So that means a negative charge on oxygen is more stable compared to a negative charge on carbon when already there is an oxygen which can be present. So that means even though we can write more resonance structures, the contribution from these structures where the carbon is having a negative charge is less stable compared to a negative charge on oxygen. So that is the reason carboxylates are more stabilized compared to phenoxide ions. So this way, we can try to go to the next level of understanding that will help us clear many of the doubts and the questions also. And you can also draw like this kind of holistic thing. Like I just want to learn about rearrangement. So what are all the different types of rearrangement? One is change in carbon skeleton. Otherwise, loss of groups or other electron deficient terminus. So this way, these are all the major things. And no change in carbon skeleton. So no change in carbon skeleton means this is basically 1,2 hydride shift. It may be primary to secondary or secondary to tertiary, or it may also be allylic. So all these things in a single paper, I can write down. I can condense the entire rearrangement, maybe some 6 to 8 different reactions in one single piece of paper. So this helps me remember many things very quickly. So what are the crucial things? One is no change in the carbon skeleton. Other one is change in carbon skeleton or loss of group. So these are all the three major things, and I have to just have these things together. And when we go to the carbon skeleton, we can say neopentyl, Wagner, Merwin, or pinnacle rearrangements. Like that, we can go to that. And then we can also study about, okay, let us focus on pinnacle rearrangement. So where the first H plus is actually added. So that is what we are going to see, whether it happens here or not. So then the rearrangement actually happens. So here is the question. If there are different substituents, whether it will add to carbon 1 or carbon 2. How do we decide that? So this we cannot decide now. But how it is being decided, which is the most stable carbocation, that decides where the H plus will add. So we are actually going forward to see what is the backward steps. And because most of the organic chemistry reactions follow the microscopic reversibility principle. So keep that in mind. Every step is possible. Which is the most stable, that is the path everybody will follow. That does not mean the other path is not at all followed. So that is the reason organic chemistry always gives mixture of product. The reactions are not complete immediately. They take some time, and you also get different type of product depending on what is the changes or the solvents you change or other things you change. They give different type of product because every possibility exists and every possibility may happen. So that is one thing you have to remember. But when we study, we only focus on one thing. Oh, stability of carbocation alone. But that gives the major product. That does not mean that other products are not formed. So this clear understanding we have to have. I think it is 11:50. Can we stop here, sir, or can I go for a few more minutes? Any questions?
Sir, can you hear me?
Yeah.
So another 5 minutes, sir. Yeah.
Sure.
Yeah.
Thank you.
Yeah.
No problem.
The next professor is here.
Hmm.
So please try to complete within the 5 minutes.
So here what we do is like whether path A or path B will follow is purely based on the stability of the carbocation that is formed. So here we have two phenyl rings. So they stabilize the carbocation much better compared to here there is only two methyl groups. So methyl group can only stabilize through inductive effect. Here it can be stabilized through resonance effect. So resonance outweighs inductive. So we can easily figure it out what or where the initial addition of H plus will take place. We can easily understand that. So similarly, if you are going to study about the reactions also, synthesis of alcohol is the one we are talking about. We can make it from carbonyl compound. Here again, there are two major categories. One is like change in carbon number. Another one is no change in carbon number and the change in carbon number. These are all the two things. And alcohol can also be synthesized from groups other than carbonyl compounds. So these are all the major categories. And then in the major category, what you will go? No change in carbon means it may be reduction of ketones, aldehydes, or carboxylic acids. Here are the examples like sodium borohydride, lithium aluminum hydride, or diol H can be used for the reduction. And if we look at the change in carbon, we can think of Grignard reaction, especially if we take the formaldehyde, acetaldehyde, or any other aldehyde or ketone and esters, then we end up with the primary, secondary, or tertiary alcohol. In this case, we are actually adding this R group. So that means the change in the carbon numbers. So alcohol can be prepared by Grignard reaction where there is a change in carbon numbers. So this also we can understand. And if we go to the other carbonyl groups, here again we have the two difference. No change in carbon numbers, change in carbon numbers. So when we talk about no change in carbon number, it may be hydrolysis of alkyl halides, or in the case we can also go with hydration reaction. So we then talk about alkenes. In the alkene, we have both mercuric acetate reaction or hydroboration reaction. One follows Markovnikov addition, another one follows anti-Markovnikov addition. So this way, in a single slide, you can actually cover the entire reactions related to synthesis of alcohol. Of course, change in numbers, we can still use the Grignard reaction with respect to alkyl halide, not with respect to the aldehyde or ketones. Here we can talk about the other substrate, which is the alkyl halide. And you can also write like a small piece of paper, some important things, how a particular reaction takes place. So we have the X radical addition. So the radical can abstract a primary hydrogen or a secondary hydrogen. So that leads to what type of different radical and where the substitution will actually take place. So the N-propyl halide will be formed or isopropyl halide will be formed, or two possibilities. Now, the next thing you have to understand is stability of the radical. So primary versus secondary versus tertiary. Tertiary radicals are more stable than the primary one, that we know. So based on that, we can say whether isopropyl halide will be formed or N-propyl halide will be formed, we can find out. And also reactivity and selectivity. So in the case of chlorination, we have an early transition state, and in the case of bromination, we have a late transition state. So this also can be included to find out what is the product that will be formed. So for every reaction, if you just break down what are all the crucial points, what are all the crucial things happening, then it helps you prepare for your any of the examination, not only for CSIR, even for your university examinations, you can actually use it. Okay, sir. Any questions you have? Sir, any questions from the participants?
No, no questions. No questions, Balaji. You were very clear.
No, that is very bad. Actually, that means I didn't do my job properly. Either it was too simple or it was too difficult. So ரெண்டுமே வந்து சரி கிடையாது. ஏதாவது ஒரு கேள்வி கேளுங்க, because any question is fine. சார் நீங்க எந்த ஊர்னு கூட கேட்கலாம், தப்பே கிடையாது. கெமிஸ்ட்ரி ரிலேட்டடா தான் இருக்கணும்னு இல்லை, ஏதாவது ஒரு கேள்வி கேளுங்க. You have to ask one question at least.
Louder.
Sir.
Yeah, you can ask. You will find out.
Yeah, சொல்லுங்க.
Sir, how can we approach a question from the competitive questions? how can we approach a question from the?
See, that's what that's what I said. Like in that first slide where I had shown about the CSR examination, I had actually elaborately, because you cannot follow one shoe fits all technique, we say. Like, I mean, one process cannot be applied to all the problems. You have to, the approach for each problem will be different. So that the only thing is which to use actually depends on that particular problem. Say for cut something, okay? You go to the 5-star hotel chef, he will 28.
Balaji, your voice is getting cut.
If the 2 knife and the 27 knife, they will do the same job. But the way in which the expert uses are different. Similarly, the same problems approach. If you want to go follow exactly like the 27 knife approach, so we have to use different approaches for different problems. There is nothing like one simple approach, because all questions are different. And I had seen many of the questions and I have also solved many of them. As I mentioned, there were 2 or 3 things which are very common. One is like you can rule out some possibilities by looking at the problem. That is one approach you can do, but that will not be applicable to all the problems. But majority of the problems, you can at least rule out 1 or 2 possibilities. Then you will be left with only 2 options. Now you have to figure it out, because you have a negative valuation. So that is also the biggest problem. You cannot take it like, okay, close your eyes and just say A or B. No, that doesn't work. So you have to apply some logic. So how do you apply that logic? That differs. And that is the reason you try to understand most of the reactions by its mechanism. Then we can figure it out, at least something are possible. Say recently, I think if some of you had read any literature and other thing, the bread rule is one important rule we talk about. In the bread rule, what is the rule? But I think Professor Karg from UCLA, he had actually developed a bridge that can have a double bond. So this is a latest development. Now, whatever we know and whatever even Mason-Hammer complex, when we talk about, some people say, yes, this can be isolated, and some people say, no, the reaction mechanism or path is entirely different. So basically, the process by which the product is formed can change. But what is the product that is formed? That is the most important, and we mainly focus on the end product. Maybe the mechanism may be a little bit different. That is okay. So to approach that, you try to rule out what cannot happen and then try to figure it out what is possible. So that also we have to apply, and there are other questions which do not take too much difficulty to solve the thing. And one important thing you have to remember is, if the question appears very simple, then that is the most difficult one. Okay, so you cannot simply just look at that and say, oh, everything is very simple, I will solve it, but you will always end up with the wrong answer. So you have to look at what are all the possibilities, rule out the possibilities, and this is like a Sherlock Holmes, how he identifies the culprit. What Sherlock Holmes does is simple, very simple. He will rule out everything, but what he will always say is improbable may happen, impossible can never happen. So this is the main thing we also can follow. Impossible means that can never happen. Rule out all those things. Improbable may be possible, and he solves every problem based on this simple approach. You can also use the same concept for solving your CSR exams. And actually, you see that course. So there, I think around 22 hours of videos are there, and I had covered from A to Z all the questions, including photochemistry and everything I have covered. So there, every problem, there is always some sample problems, how it can be approached, everything is given. So please watch that video, then you will get more information and insights. And one more thing, if somebody wants to contact, I think Professor Mangal Sundar can share my contact as he mentioned. You type BS Balaji and JNU, my name will come as the first one. My email address is there, my mobile number is there. You can call me, contact me, email me, WhatsApp me, Telegram me, anything you want, you can always contact me. No issues.
Thank you, Dr. Balaji. So we want to, on behalf of this group, we want to express our sincere thanks to you for, as late as today morning only, I came to know that you are available. So for the time being, we were thinking that we will manage this program with faculty from IIT, but now it has become national program. Thank you for making it happen. Okay? So I will be in touch with you. Yeah.
Good, sir. Thank you, sir.
I'll be in touch with you because this is a seed program for a much larger activity in the next coming months. So we will be in touch with you, okay? In order for you to come here sometime when that program schedule happens. Thank you very much. I have the next speaker.
You can take feedback from the students. I think, yeah, students are very happy. Like anything and everything, you can approach me.
I will do that. I'll also encourage them to do that. Okay. Thank you. Thank you very much. Okay.